Yeah, so hello everyone. So this is a question from JEE Mains 2026, 28 Jan evening, and you can pause your screen and go through the question. So the question is, structures of four disaccharides are given below. Among the given disaccharides, the non-reducing sugar is. Okay. So basically they're asking us about the non-reducing sugar. Okay. So this involves the chapters involved are biomolecules and aldehydes, ketones, and carboxylic acid, right? So before we go and see the options, I would like to discuss what's what does this word mean, non-reducing sugar. Okay, so sugar or carbohydrate, it's the same thing. We know what are carbohydrates, right? So all those carbohydrates which contain aldehydic or ketonic group in hemiacetal or hemiketal form. Okay, those carbohydrates that contain the aldehyde or ketone in this hemiketal or hemiacetal or hemiketal form, and they reduce Tollens reagent and Felling's solution. So those guys are known as reducing carbohydrates or sugars. That's the definition. And those carbohydrates or sugars which don't reduce, okay, which don't reduce Tollens reagent or Felling's solution, so they are known as non-reducing carbohydrates or sugars. Okay, so before we go and see the options, we should know that all the monosaccharides, okay, for example glucose, fructose, galactose, all the monosaccharides, so they are reducing. Okay, for disaccharides it depends. Okay, disaccharides can be reducing as well as non-reducing. For example, sucrose is non-reducing. In sucrose, as we will see, the aldehyde or the ketone groups are they are busy in, so the aldehyde or ketone group, they are busy in forming the glycosidic linkage, so they are not free. Okay, hence they cannot revert back to the aldehyde or ketone form and reduce these you know um, reagents like Tollens reagent or Fehling solution. Okay, but we know, so this is non-reducing, but there are certain disaccharides, for example maltose, lactose, so they are reducing. So everything depends upon the structure. Okay, so and also before we go and see the options, we need to know, we need to understand the structure of alpha D glucose and beta D fructose. So this is the structure of alpha D glucose. Okay, and here I will give numbers. The numbers are very important: 1 2 3 4 5 6. So these numbers are for the carbon atoms, and you can see the first carbon is my, I am putting a star there. So the first carbon is the aldehydic or the aldehydic carbon or the reducing center. Okay, for glucose, for alpha D glucose. Similarly, we have beta D fructose. So in beta D fructose, I will give the numbers 1 2 3 4 5 6, and you can see here this second carbon is the reducing center or the ketonic group which is existing as hemiketal form. This is the hemiketal form, and here the number one carbon is existing as the hemiacetal form. Okay, so these are some of the prerequisites to solve the question. Okay, so now coming to the options. So this is the first option which is there in front of us, and if you see clearly, this is glucose, alpha D glucose, and this is beta D fructose. So this is technically sucrose, and we know sucrose is non-reducing. Okay, so we need to understand why it is non-reducing. Okay, so in alpha D glucose, I will give the numbers 1 2 3 4 5 6. In uh, beta fructose, beta D fructose, I will give the numbers. So this is 1 2 3 4 5 6. Okay, so I'm putting the stars at the reducing centers. So This is the reducing center of the alpha D glucose. This is the reducing center of beta fructose. And you can see both are busy in forming a glycosidic linkage. None of them are free to revert back to the aldehyde or the ketone form and reduce the Fehling solution or tolerance reagent. So therefore, this is non-reducing. This is non-reducing. The next options, so this is non-reducing. Let us look at next options. Okay, so if you look at this particular option, so both of them are alpha D glucose. This is also alpha D glucose. This is also alpha D glucose. And let's give numbers again to them. 1 2 3 4 5 6. 1 2 3 4 5 6. Okay, I'm putting the stars in the reducing centers. So as you can see, in this particular disaccharide, this particular reducing center is busy in forming the glycosidic linkage, but this particular center, this particular carbon is not busy. It can revert back to the aldehyde form, and hence it reduces the tolerance reagent or the Fehling solution. So therefore, this is reducing, and this is actually maltose, because maltose is made up of 2 alpha D glucose. Let us look at the third option. In the third option, let's give them numbers again. So this is 1 2 3 4 5 6. Let's give the numbers 1 2 3 4 5 6. And you can see here, this is beta D glucose. And this is also beta D glucose. The individual monosaccharides are beta D glucose. And you can see here again, in this particular disaccharide, the one of the reducing center, that is, let's put a star here and let's put a star here. So this is the reducing center. This is busy in forming a glycosidic linkage, understood. But here this carbon, this particular carbon is free. It can revert back to the aldehydic form, and it can reduce Tollens or Fehling's reagents. So therefore, this is also reducing. And let's come to the last option. In the last option, again, let's give them numbers 1 2 3 4 5 6. 1 2 3 4 5 6. So you can see here again, in this particular disaccharide, this is the reducing center and this is the reducing center. And you can see this particular reducing center is busy in forming a glycosidic linkage. This is the glycosidic linkage. And this particular carbon is free. It is not involved in a glycosidic linkage, and hence it can revert back to the aldehydic form, and it can reduce your Tollens reagent or Fehling solution. So therefore, this is also reducing. This is a reducing disaccharide or reducing carbohydrate. So therefore, since the question is asking us which one of the following is non-reducing, therefore the answer will be A, that is sucrose. Sucrose is non-reducing in nature. Thank you.